Okay, in this lesson we are going to learn how to find the equation of a sinusoidal function by looking at the graph or when given some key information about the graph. So our first example here says determine the equation of the following graph as a sine function and as a cosine function. So the thing with sinusoidal functions is because of the periodic nature of their graph and because the sine and cosine functions are basically just translations of each other, that is to say they are essentially the same graph, just shifted one direction or the other. Because of that, we can use sine or cosine functions to represent a graph such as the one in example 1. And so what's going to change there is for the most part the phase shift. Okay, so we're going to come up with two different equations for this graph, and we'll start by finding a sine curve, okay, a sine function, sorry, to represent this curve. So in order to do that, we're going to draw the box that we've been using in order to graph the functions. Okay, we're going to draw the box around sort of the first cycle of this graph that looks like a sine curve. Now remember, a sine curve within that box we were drawing has key points along the axis on both sides of the box and in the middle. So traveling along the axis of the graph, which would be right along here, okay, we're going to go to where we first hit a point on the graph, which would be right there. So we're going to draw the box, and it's rather difficult for me to do this on the iPad, but a little easier for you in your note, hopefully. And we're going to draw it all the way to the end of that first wave, like that. Okay, and then from there, we're going to identify some of the key points, features that is, about this graph. So for one thing, we can see that the amplitude is 2. So that means our A value is either going to be 2 or -2. Now in our case, looking within that box, because we go down to a minimum point first, we know that the A value is going to be -2. Okay, next thing. We can see, not overly clearly, mind you, but from this graph we can sort of see what the period of the graph is. Now pay attention to the scale on the x-axis, okay, which appears to be increasing by 2, given the numbers that are marked off there. So in order to find our k value, we're going to take 360 degrees and divide it by the period. Now when you were coming up with the equation, or sorry, when you had the equation and you were trying to find the period, we were doing the opposite, right? So let's write a note here that says, remember, when we were finding the period, when you had the equation, you take 360 degrees and divide it by k. So we're just doing the opposite here, because in this case we know the period. Now it's a little bit difficult to see, but it's approximately 10. So about every 10, whatever this is, seconds or what have you, this graph is repeating itself. So that tells me the k value in the equation is going to be 36. So now we have our A value, our k value. We said the axis is at y equals 1. And that tells us that the c value in the equation is 1. And the last parameter we have to find is the d value. And again, this one's a little bit difficult to see. It appears that that is shifted a little more than 2, as you say, to the right. So I would say the phase shift is somewhere around, let's say approximately 2.2, which means D is 2.2 degrees. Or 2.2, I guess we don't know that these are degrees, but let's just erase the unit. Sometimes the quantity on the x-axis is time or something different, so we won't fill in any units there. Okay, so now we have to take these parameters and fill them in to the formula. Now let's remember the general formula for a sine function looks like this. Y equals A sine K. Oh, every now and then this thing decides to stop writing. K. Come on. Times X. Oh, for goodness sakes. Minus D. Plus C. This is supposed to be an X. There we go. Okay, so we have to fill our values in to this formula. So as a sine curve, this equation could be y equals -2 times the sine of 36 bracket x minus 2.2 bracket plus 1. Now it says find an equation as a sine function as well as a cosine function. So as a cosine function, if I was to draw, let me get a different color going here. If I was to draw a box around the first wave of this as a cosine function, the first maximum point is right here on the y-axis, as it is for the graph of y equals cos x. So there's no phase shift here. If I look at this as a cosine function, my first wave would be right here. Okay, so let's write, actually first of all, let's say here's part of our answer. Okay, that's as a sine function. Now, as a cosine function, there is no phase shift. So everything else about this equation is going to be the same, well, other than the fact that as a cosine function, it does start at a max point at the left side of the box. So A is now going to be positive. So there's also no reflection here. So let's say as a cosine function, there's no phase shift and no reflection in the x-axis. Okay, so as a cosine function, we'll write y equals 2 cos 36x plus 1. And we don't really need the brackets in this one because there's no phase shift. Okay, so now we have our two equations as a sine curve and as a cosine curve. All right, our next question here, we're given sort of the same information, but in words and not with the graph. Now, when that happens, you may still find it helpful to make a bit of a sketch, okay, so that you can sort of get this straight in your head. So it says a sinusoidal function has an amplitude of 2, a period of 180, and a maximum point at 0, 3. Find the equation in two different ways. So if we make a little bit of a sketch here, okay, so it says we have a maximum point at 0, 3. So right up here, let me make a different color. Right up here at 3, we have our first max point. Okay, and the period of the graph is 180 degrees. So that means at 180 degrees, I have another max point. And one full cycle in between those two. Now, it also says the amplitude is 2 units. So that tells me something about the axis. That tells me that the axis is at y equals 1, right along here. Okay, and that tells me that I have a minimum at -1, which will occur halfway in the middle here, so at 90 degrees. try to write that a little better. So at 90 degrees, we have a minimum point, and it will be at -1. I leave myself a lot of room to write that. So right here, we'll have a minimum. Okay, and this is at 90. It's very difficult to write small with this pen. There, that's a little better. Okay, so we've got a max of 3, another max 180 degrees later, which means there'd be a minimum halfway in between them. And along the axis, we would have points halfway in between those. So now we're going to join those together. Okay, and that sketch should help me find the equation for this function, or 2 equations for this function. So now we can see that the a value here will be 2 or -2. And how will we decide? Well, let's find this equation as a cosine function first. So as a cosine function, we'll draw the box around the first cycle of the curve, like so. So there'll be no phase shift at all. And since we are starting at the max point, a will be 2. Now, the period of this graph, we said, is 180 degrees. So from there, I can find the k value. So k will be 360 divided by 180, which is 2. So now I have the k value. There's no phase shift as a cosine curve, but there is a vertical translation 1 unit up. So since the axis is at y equals 1 again, we know that the c value is 1. So as a cosine curve, we could write y equals 2 cos 2x plus 1. Now as a sine function, I would want to draw the box starting here at this point along the axis, okay, and ending 180 degrees later. So the rest of this function would look like that over here. So this would be the first cycle as a sine curve. So now I would have a phase shift in order to express this as a sine curve. Oh, it doesn't want to move with me. I'll have to write to the side here. So as a sine curve, okay, there will be no, there will be a phase shift of 45 degrees to the right. And also notice as the sine curve starting at the first sort of root there, first point along the axis, we're going down to a minimum first, then increasing. That tells me the a value is also going to be negative. So it'll be y equals -2 sine. Now in brackets, the phase shift is now 45 degrees. So we're going to say 2x minus 45, since it's 45 degrees to the right. And I'm sorry, I'm running out of room here, but I would still have a plus 1 at the end of that equation. So y equals -2 times the sine of, in brackets, 2x minus 45, and then outside of the brackets, plus 1. All right, we have one more example, but I'm going to need you to go to video 2 for that example.